Okay. So we are moving on into our next chapter here. And this chapter is on hypothesis testing, okay? Yes, I believe chapter 8. So we are dealing with hypothesis testing, okay? And hypothesis testing is all about, a method of statistical inference. Okay? So this is all about using a sample of data to make a conclusion about what? Statistical inference. We always say we want to make a conclusion from limited data. So if we're using a sample of data, we're going to make a conclusion about what? Okay, it could be about the proportion, but specifically, what body are we trying to make a conclusion about? The population. That's what we want to make a conclusion. Okay, so we're making a conclusion about the population. And today, the types of conclusions we're making will be about the proportion that exists in a population. Okay, but and next week we'll learn about making conclusions about the mean of a population. Okay, and so in terms of content that we are covering, we're covering new content this week, and we will cover new content next week. The following week will be mostly review, and then the week after that is our final exam. So we're fast approaching the end of our class here. Okay, so or wait, maybe there's another week thrown in there. Let me. There's another week. Yes, I'm sorry. Huh? I'll be dropping the two. There's a total of 8 quizzes, and I'll be dropping the 2 lowest grades. Okay. Okay. All right. So using a sample of data to make a conclusion about the population, and so today we will cover hypothesis testing for proportions that exist in our population. Okay? And so we will ask questions like, could the proportion of females in our population be 50%? Or do we have evidence that the proportion is something other than 50%? So this is a statistical question, we're going to look at some data and we're going to ask, could the proportion of females in our population be 50%? Or do we have evidence that that the proportion is something other than 50%? Okay, and we can just replace, these types of questions with, whatever other topic we are asking about. So another one could be, do we have evidence that over 80% of the population believe that over 80% of the population believe the Earth is round, or whatever it might be, okay? So notice our questions always ask, do we have evidence of some trait, some property, okay? So we're asking, do we have evidence? So all of our conclusions are based on evidence, or based on data that we collect. That we collect, or has been collected, I should say. Okay, so hypothesis testing, we're always asking questions, about something like this. So far, so good? Okay, next slide. No. All right, here I go. All right, so what we do is the process, in hypothesis testing, we always start off with some kind of question, and then we turn the question into a pair of hypotheses that we can test, okay? So we always begin with a question, okay, and then we turn the question into a pair of hypotheses that can be tested. Okay, and these hypotheses represent basically two possibilities that exist. Okay. Okay, and either one or the other must be true, and we are going to use our evidence to decide whether we can reject one hypothesis or not, okay? Represent two possibilities. So we have the two hypotheses are we have the null hypothesis okay, which we write as H0. The 0 is a subscript. Okay, and then we have the alternative hypothesis. And that is the alternative. Now, and the way our thinking works is that we always assume, we begin our process under the assumption that the null hypothesis, that H0, is true. Okay. So we begin our process assuming that one of these statements, specifically the null hypothesis, we begin our process assuming that that thing is true. Okay? And if that thing is true, then essentially the world should look a certain way. Okay? And if the things we see fit that assumption or belief, then we have no reason to doubt our initial assumption. However, if we find things, if our evidence goes contrary to these set of beliefs, then we might be forced to reject our null hypothesis. Okay? So, for example, maybe you imagine living in some dystopian world, okay? And you're told that so-and-so, great leader is a wonderful person, okay? And then so you start off your life believing great leader is a wonderful person, okay? And if the evidence, you go through your life and there's nothing that contradicts that statement, you see him and he's doing good things and he's nice and all of this, then you have no reason to doubt this initial assumption that great leader is wonderful. Okay, but as you are living, perhaps maybe you get a glimpse of the outside world or whatever, and then you start to recognize all of these other shady things that great leader does or whatever, then maybe the evidence that you've encountered now causes you to reject that null hypothesis, because if the null hypothesis were true, if great leader really was a great person, then all of these things that you are witnessing should not be possible, right? Does this line of thinking make sense? Yeah.
Well, if the great leader, has Dennis Rodman play basketball, he must be the greatest person on earth.
Yes, great leader. Great leader is best leader, right? So this is kind of a silly. So maybe I'll write this out and we'll explore this topic with kind of just this silly scenario, but then we can apply it to. It is funny though. I don't know why I chose great leader when it has now become synonymous with North Korea, right? So I want to ask our international friends from Sweden. Do you guys kind of like poke fun of North Korea, or is this just a strictly American thing?
I think it's
mostly American, right? Like we make movies about. We don't make fun of anybody, okay? Yeah. So America, we like to pick on North Korea, and North Korea hates us in return. Yes.
Going back to Sweden, is like South Korea one of your allies?
South Korea is one of America's allies.
Right.
And if
fire, so why would
yeah. So, well, who knows, right? I think everybody Well, I don't know. I don't know what everybody thinks. Okay, anyway, so let me write this down. We begin our process under the assumption that the null hypothesis is true, okay? If our data does not contradict this assumption, then we continue to believe that the null hypothesis is true. Okay? Notice this does not prove that it is true, but we just continue in our current state of belief. Okay? Okay, on the other hand, if our data contradicts the null hypothesis, then we have reason to believe that the null hypothesis is wrong. Okay. We then conclude that the alternative is true. Okay, so is this okay? I'll let you guys write this down. Okay, so yes, we start off with one assumption, that the null hypothesis is true, and it's not going to be great leader is perfect, and the alternative great leader is not perfect, but it's going to be something that we can test with probability, okay? And when we say our data does not contradict this assumption, basically we're just asking, you know, could we observe a certain set of data under the null hypothesis, or is it incredibly unlikely to observe this set of data? And if it is incredibly unlikely to observe that set of data, then we say our data contradicts the null hypothesis, the H0. So we'll try out an example, and I'll try to explain every step of the way. And I hope this will make some sense as far as hypothesis testing goes. All right, can I flip to the next slide? Okay, so let's say, well, this could be silly. We'll make it silly. Okay, so great leader says, you know, our country is great because only 1% of the population is unemployed. Okay? Something like that, okay? So basically, his statement is the proportion, okay? So when we look at it from a statistical perspective, we're going to say that he is saying, great leader says, P, the proportion that is unemployed, is 0.01. P is proportion unemployed. Okay. And we want to ask a question. Okay, so we have a question. Do we have evidence that the proportion of unemployed is actually higher than 1%? Okay? This is what we're going to ask. Okay, and so collecting data might be illegal in great country, but we're going to do it, and so we collect data. Okay, and somehow we get a random sample. Uh, 5,020 people. Okay, and we find that 185 are unemployed. Okay, does our evidence prove that great leader's statement is false? Okay, applying our question. Does our data convince us great leader's statement is false? Does it?
No.
Yes? No? Okay, well, let's see. Okay? So we're going to create a pair of hypotheses. Our null hypothesis is going to be what? So our null hypothesis is going to be that the proportion that's unemployed is indeed 1%. So our null hypothesis basically says great leader speaks the truth. The proportion that's unemployed is only 1%. The alternative would be that great leader is not speaking the truth, and the proportion of unemployed people is actually higher than 1%. Okay? If great leaders spoke the truth, how many people would we expect to find unemployed in our sample? What's that?
10%?
We would expect to find that 1% of our 5,020 people to be unemployed. So how many people would that be? We would expect to see 50.2 people to be unemployed. Does that make sense? Okay. So if the null hypothesis were true, we expect 5020 times 0.01, 50.2 people to be unemployed. What does our data show?
3.69.
Our data says that 185 are unemployed, okay? So is there, a mismatch between what our data shows and what we're expecting if Great Leader was speaking the truth? There is a mismatch, right? What if our data showed that only 53 people were unemployed? Would that be a mismatch? Okay, so when we see 185, that's a mismatch. But 53 people versus what we expect of 50.2 doesn't seem to be that much of a mismatch. Okay, and we would have to do some statistical testing, and we're going to do statistical testing here, but we could do statistical testing in the other case as well. Did you have a question?
Where do we draw the line?
Yeah, that's a very good question. So we'll talk about where we draw the line, and it all depends on this next set of calculations that we do, okay? So what we would say, okay, now when nobody dares challenge a great leader, but let's say we did, okay, and we said, well, if you were speaking the truth, we should have only found 50.2 people to be unemployed, and what we actually found was 185. How do you explain that? Great Leader could just say, you happened to get a weird random sample that just happened to have too many unemployed people. Would you believe him? But is it possibly, could that actually be the case?
Yes.
That we just happened to get a random sample that happened to have too many unemployed people? Okay? That could be the case, but we can find the probability of just such a coincidence happening. Okay? All right, so we can say, well, all right, let's just say that that's a possibility. Okay, it is a possibility, but we could find the probability of this coincidence happening. Okay, so what's your gut instinct? Does your gut instinct say the probability of this happening just by coincidence is high, or the probability of this happening by coincidence is low? Low, right? Okay, and because the probability of it happening by coincidence is low, that causes us to believe the statement that Great Leader is making is false. Does this make sense? So I'm going to write this out, and then we'll do the math behind it, okay? So, I'm going to write, Great Leader says, you happened to just get, get a weird sample with too many unemployed people, just by coincidence. Okay, or another word, just by random chance. Okay, so technically, yes, it is possible that we got 185 unemployed people by coincidence. Okay. But we will calculate the probability of this happening by coincidence. Okay, and our gut tells us that the probability of it happening by coincidence is very low. Would it be helpful if I dim these front lights? I don't. Does that?
Helps,
Yeah.
yeah.
Okay. Does that hurt our front row though?
No.
Front row's okay? Still writing? Okay. So we'll do that. And I'll let you guys write this down. And I just want to make sure that this line of reasoning makes sense, because this line of reasoning is very important as it's going to play out in the rest of our lesson today. Okay, so we're saying you just happen to get a weird sample by coincidence. That's what Great Leader says. And we're going to say, okay, well, technically it is possible to get this weird sample by coincidence. We'll do the calculations and we'll find out what is the probability of getting this sample if what Great Leader is saying is actually true. Okay? So I'm going to flip to the next slide. Is that all right? Okay. And we're going to calculate what's called the p-value. And so here's a definition. It's a very important one. The p-value is the probability of observing our data or data that is more extreme if the null hypothesis were assumed to be true. So in our situation with Great Leader, okay, we're going to say if Great Leader tells the truth, then only 1% of the population is unemployed. Okay. We observed that 185 out of 5,020, so what is this? This is 185 divided by 5020, about 3.036, I'm going to write this out, 0.03685 of the population is unemployed. Okay. So our p-value is, what is our p-value? Is essentially asking what is the probability that a random sample just happened to produce our data if the proportion, if the null hypothesis is true, if the proportion of unemployed really is 1%. Okay. So what's the probability that, we get this sample of 0.03685 if the proportion is just 1%. Do we know how to get this answer? Can we do this calculation? And the answer is yes, because I could rewrite this question as I think something that you are familiar with, okay, is essentially, basically we can rewrite the question as this, you know. We have a random sample of 5,020 people. Okay. 1% of the population is unemployed. Because we're assuming that the null hypothesis is true. We're assuming that indeed only 1% of the population is unemployed. And we ask, what is the probability that a random sample has a proportion of 0.03685 or more? So I'll give you guys a second to catch up writing. Okay, so can you do this calculation here? Yeah? Okay, so I'll give you guys a minute or a couple minutes to try to work out the answer to this question. So this is very similar to a question that you guys saw in your quiz, right? Or on the practice quiz. On the practice quiz it was about the Lego pieces, and on the quiz it was something else. It's very similar, except we've just replaced our numbers, and we said we're talking about unemployed people, and we've got a big sample, and we've got a big difference here. Okay, so I'll give you guys a few minutes to work this out. Please try it. And we'll come back together and go over the answer. Okay, so let's go through our answer, and like I said, for this problem I tried to write our question, our setup, into a form that you recognize from, you know, our quiz or practice quiz and things like that. Okay, so in this form what we have is a random sample of 5,020 people, so this is our n, okay, and it says 1% of the population is unemployed, so our p is equal to 0.01, okay? And our proportion, the sample that we observed, was 185 divided by 5,020, so our p hat is 0.03685, okay? And so to answer a question like this, we're gonna have to find our z-score, which is gonna be p hat minus p divided by our standard error. Okay, and so our standard error uses our p, so we use 0.01. Here, I guess I can write out the formula. 1p times 1 minus p over n. So our standard error is 0.01 times 1 minus 0.01 divided by 5,020. Okay, and so I punch this into my calculator, 0.01 times 1 minus 0.01 divided by 5020, okay? And when I do this, I get this as the number. It's probably going to show up in scientific notation if you have a Texas Instruments calculator. And I'm going to take the square root of this number, okay? So I get this very small number. I get something like 0.0014043, okay? I'm not even going to, I really don't even have to bother writing this down, okay? Because I'm just going to plug this into my z-score. So z-score will be p hat minus p divided by the standard error. So my p hat is 0.03685 minus p, which is 0.01, divided by the standard error, which is 0.0014043. Okay, so I'm going to put this in my calculator. I put this in the numerator, and I divide by this. So I'm going to write 0.03685 minus 0.01, and I close my parentheses, and then I'm going to hit the divide key. And instead of having to type out 0.001443, I'm going to just hit the answer because it's already in my screen. Okay? And then I hit equals, and I get 19.119 or 19.12. So my z is equal to 19.12. So are you guys able to follow me here? And well, whether you've done it on the calculator yourself or not, I just want to make sure that the math and the line of reasoning here makes sense. Okay, and I know some of you guys have got it. As I was walking around, some of you guys just kind of sat there with a blank. I mean, you wrote down the question and you didn't bother attempting the problem. And I always wonder, like, well, do they get it, or I'm not sure. So, these breaks in class are here for you to kind of attempt. Okay, so when we do this, we are not done, right? We have to then look up the z in our z table, right? So we try to look up 19.12 in the z table. Now, if we go to our z table, what do we see? We see the largest it goes is 3.4, and then it also has z equal to 4, 4.5, and 5.0, okay? And from the empirical rule, we know that, what do we know? We know about 68% is within 1 standard deviation, 95% is within 2 standard deviation, and almost all, 99.7, is within 3 standard deviations, right? So pretty much, when you're more than 3 standard deviations away, it's very, very unlikely to happen. And here we are at a staggering 19 standard deviations away from the mean, okay? Which means, for all intents and purposes, this never happens, okay? So if we ask, could a random sample of 5,020 people produce 185 unemployed people just from random chance? The answer is no. It could not happen by random chance. We are 19 standard deviations away, okay? Well, if we looked at the table, whatever our answer is, okay, at 5 standard deviations, the probability of something happening is 1 minus this, okay? 1 minus 0.999999713, okay? So that's like 0.000000287 or something. So that's like 3 in 10 million chance. That's 5 standard deviations away. Okay, at 19 standard deviations away, I think it's practically 0, right? Okay, so I don't have an exact number here, but that number is 0. Okay, so if we found it, okay, if we found the z, we would take that number and do 1 minus the probability to get our answer. Okay, but we didn't find it, and that's because we can't find 19.12 in the z table because it's too extreme. Okay, it is, as we might say, it is literally off the charts. Okay? Oh, and that's where the expression comes from, right? If we try to look it up on the chart, it's so extreme that it's off the charts. And so it's too extreme. So the probability of this happening by random chance is 0. Okay. So, you know, if we took our sample randomly, then this must mean Great Leader is not telling us the truth about the unemployment rate. And then we start to question everything, you know, that we've ever been told. Okay. Is this okay?
What's the unemployment rate in America right now?
It's probably like 7% or something like that. So less than 4% unemployed is,
So it's still a good country, huh?
huh?
So still a good
It's
country.
still a great country. Everybody's employed. Everybody can break rocks. Okay, is this all right? Let's see. Okay, we'll take our break now, and we'll say 10 minutes, and then we'll come back and we'll finish